Section 1.5 is our first introduction to limits. So we're going to learn the limit of a function, the definition of a limit of a function and properties of limits, techniques for evaluating limits, one-sided limits, and unbounded behavior. So what is a limit of a function? Essentially, big picture idea is we're saying as we get close to a certain x value, remember x is left to right, what's happening to the y value or the function value? So as we approach a certain x value, what's happening to a y value? And I want to highly emphasize here that it's as we approach an x value but not equal to an x value. In other words, we don't want to directly just plug in that x value. We want to know what's happening around an x value. That's the big picture idea of what a limit is. So it says a limit, in terms of, we will discuss it, is the idea of as x approaches a number, what is happening to the function value or y value. It is important to note we are talking about what happens as we approach a given x value, but not equal to that value. In other words, what happens near a point, but not at that point. Because at a point, it might be undefined, and we don't care about that. We want to know what happens near the point. So it says, consider the following graph of f of x equals x squared plus 1. What is happening to the y value as x approaches 1? Well, as we look from the left on this graph, if we come from x equals, so here's x equals 1, I'm going to come from the left. As I come from from the left, it looks like my y value is getting closer and closer to the number 2. And as I come from the right of x equals 1, I'm coming down on the graph, it looks like my y value again is getting closer and closer to a y value of 2. So we would say, it says we can see as x approaches 1 from the left or from the right, the y value is approaching 2. So rather than writing that whole entire sentence, we came up with some math language of writing that. It says that is, the limit as x approaches 2, that's the x value we're approaching, and that shouldn't say x approaches 2, that should be as x approaches 1 of the function x squared plus 1 is 2. So as x approaches 1, the y value or function value approaches 2. So how do we write that mathematically? Again, here there's another typo. I apologize for that. The limit as x approaches 1 of this function, the function was x squared plus 1, is 2. So again, I'm going to emphasize down here, we're talking about the x value. Right here, we're talking about the y value. So you give me the x value, I give you the y value. Kind of like function notation, but we're talking about as we approach a value here. So there's another way that we could determine it. The way that we just determined it is called graphically, because we looked at the graph. It says another way that we could determine this is to look at a table of values. So we take x values to the left and to the right of 1, getting closer and closer to 1. Then we find the corresponding function values by plugging in the x value to the function. So we have an x value, we plug it into the function to get the y value, and we look at what's happening to the y values as I get closer and closer to 1. So again, we do not care what actually happens at 1. So don't worry about what happens at 1, we're caring about what happens near 1. I want you to look at these first x values right here. I start off with 0.9, then I go to 0.99, then I go to 0.999. So as I go from left to right, notice I'm getting closer and closer to the value 1. Mathematically, right? So that's my x values. So what do I do with those numbers? Well, I plug those numbers into the function f of x. I plug in those values for x. So for instance, 0.9 squared plus 1, put that into your calculator and you're going to get the y values. Okay? I want you to notice what happens to the y values. It's 1.81, 1.98, 1.998. So as my x values get closer to 1, my y values get closer to 2. Let's look from the right-hand side. If I start on the right-hand side, I start with 1.1, and then I go to 1.01, and then 1.001. Notice I'm getting closer and closer to the value 1 there. And again, note that my y values, which would be 2.21, 2.02, 2.002, those numbers are getting closer and closer mathematically, again, to the number 2. So as I approach 1 from the left, my y value is approaching 2. As I approach x equals 1 from the right, my y value is approaching 2. And because it's the same from both sides, we are able to say the limit is 2. Again, we already said it just above that, but let me restate that. What we just proved or showed is the limit as x approaches 1, as my x values get closer and closer to 1, of this function, again that function being x squared plus 1, my y value approached 2. So we just evaluated our first limit both graphically, looking at the picture, look at the x values, what's the y value approaching, and using a table. The table plugging in the numbers and indicating what our y value is approaching.